Hi, this is Mickey Geek and I'm Dan, and this is the second video in my Summer of CNC series. Last time we did a baseline with the OX CNC and the xPro CNC controller that I originally bought it with. This time we're rewiring to the Duet Wi-Fi. So just to quickly kind of recap what the differences are, both in terms of the electronics and my approach since originally setting up. This was the xPro. I pretty much did the bare minimum setup. These are all screw terminals, so all of the wires just go into the right places, get screwed in place. This was my fabulous enclosure. I basically just put it in this Tupperware with some holes cut in the sides to allow wires into the right places. A couple of case fans tucked on the side to blow air across it. Job's a good one. Now I will say, during the couple of years that I used it, I did have a couple of occasions when the CNC started behaving really bizarrely, and it turned out the fans had stopped blowing, and so it is very clear that heat is a problem for these things, and so airflow is important. So, contrasting, this is the Duet Wi-Fi. I 3D printed this enclosure. There's a wonderful thingiverse object that was already made, so it's nicely screwed in place. This is actually on a platform, so there's space for airflow to go underneath it and over it. I've got a couple of custom bought, like specifically for this bought 50mm fans rather than running off just the old case fans. They fit at the end. So the main thing, or the key difference from a setup point of view, is that this board uses all of these little type connectors that plug onto the board. So where I previously had bare wires that screwed in screw terminals, I now have to fit all of these. So in the past I would probably have done this kind of thing with pliers or maybe even solder, and it's fiddly and I would have made a mess of it and it would have been frustrating. Doubly so because most of the wires I'm dealing with now are like on and attached to the machine. I don't really want to have to take everything off just to make this bit easier. So I actually bought myself a proper tool for the job, which you know, is a great idea if you can do it. So this is a proper crimping tool for all sorts of different things. In fact, it has replaceable jaws, so you can put different things in for different crimping jobs. But this is the jaw for these type of connectors. So hopefully this is going to make this relatively painless. The first thing I'm going to do is cut off the connectors that came with the fans and apply a new connector for that. Then I'm going to go crimp all of the wires for all the motors, and I guess I'm going to need to put some proper connectors on the end of the end stops and the probe. And then the one thing that is a screw connector still on the Duet is the mains power in. The other thing I'm going to need to figure out is connecting this little fella. So with the xPro, it provides a 0 to 5 volt essentially analog output that I could feed into the VFD for the spindle to control the RPMs. The Duet only has digital pulse width modulation output for that, and this board bridges the gap. So this takes a pulse width modulated input and turns it into I think a 0 to 10 volt output. I can reconfigure the VFD to accept that as its signal. So I'm going to need to figure that out. I'm also going to need to figure out where to mount this in the fancy enclosure. At the moment I'm thinking what I'll probably do is like screw or bolt it to the lid, and then this thing screws on and hopefully end up with a proper, neat, real looking enclosure. Almost like I know what I'm doing. Well, we'll see how far we get on with that. So, crimping. Let's do that. So first of all, we're just gonna clip the end off of this and then wire strip a little bit of gap, and hopefully this will go nicely. I'll bring you in for a close-up for that. So the principle of the crimp is that you take these tiny little metal pieces here and you place them essentially, I guess, sort of upside down or open side down into this, and there's a ridge line in the middle of the jaw, so the front half is getting crimped completely flat and the back half is getting crimped less so. So basically the idea is you want the bare wire to end up in that section that's getting crimped completely flat, and then the sheathed wire to be in the back half to get gripped. So in theory, what I might do, since this is such a thin wire, is just fold over so we have a little bit more to grip on. I'm going to stick it in to about there, and then just close the jaw. Hopefully you can see that that has crimped over the wire and gripped onto the sheath, and hopefully that's then ready to insert into the connector. So let's do that once more. Now I would say these then slide in perfectly, but they are a fiddly. If there is a better way to do this, I do not know it. I use a sharp pointy awl to kind of get in and help shove it into the end, and you need to make sure that that these nodules do pop into the end here, otherwise when you plug it in it'll just push them right back out again. So hopefully that's done, and that will clip onto the board, and that's both fans wired in. So you've seen the basic idea. I now have 16 motor wires to do. These are all nicely soldered and tinned, so it should be pretty straightforward just to crimp them on. Not the most exciting thing. Cue 16 crimping operations. Okay, now that we're all crimped up, I need to start poking them into the little plastic connectors. Obviously the important part here is that we get the wires in the right order. Basically there are two pairs, so I think the main thing is that you get the pairs correct. I don't think it matters super critically which order each pair goes in, but I will be following, I think, blue and green, red and yellow, he says, looking to check. I did of course take a photo of the setup that I had before I unwired everything. Oh, yep, blue, yellow, green, red. Glad I checked. Blue, yellow, green, red. So let's just stick those in this way. Now, hopefully, these motor wires are a little heavier gauge than the fan wires, so I do have just enough to be able to actually push them in without having to play with the pokey stick. So that is useful. Blue and yellow. One down, 3 to go. I'm not really going to show you all of that. You get it. You put the plugs in and you end up with connectors. So now I basically need to actually put the board in place on the machine and start plugging things in and routing wires. Problem is, electronics go on the back, and this is kind of a faff to get to. But Dan, why did you put your CNC machine on wheels? So I can do that and get to the back. Now, I only needed to move it like a foot out just so I could get behind here. This will give me a lot better access, and then I can push it back later. So the first thing I'm going to do is mount the Duet to the brackets I have back here. The brackets I made, I guess, a couple of years ago for the xPro. Just a pretty simple piece of welded steel, but I've got some holes positioned just so I can drop a couple of bolts through and hold this 3D printed enclosure in place. I think I've decided that I'm going to do it this way round. Most of the wiring is going to come in this side though, maybe I'll do it this way around. Yeah, I'll do it this way around. The thing is, it's like I want the cable runs aren't massive, so it's a question of whether I put the sockets further from the back of the machine or which way in I lead the wires. Let's see. So this would be the second Y-axis cable, and I think I would have to come in this side, which I think is fine. The other two important ones are the motor for the Z-axis and X-axis. I think that's probably okay to come in that side. Yeah, let's get this thing bolted down and do some wiring. Here, which have some holes drilled just to accept these little bolts. Let's see what we're going to do with some of these things. I may need to extend some of these wires. I think that needs to come in like that. This is the Z-axis sensor. Say sensor, Z-stop, I guess. So that's going to go on like that as I put these in. So this is X. And this is Z. Now I believe that for the dual Y-axis we're reusing, we have one Y and one E0 that we're reusing. Here we have from here the right hand Y carriage, Y motor. We have the X-axis motor, the left hand Y motor and the Z motor connected, all the same wiring pattern. Then we have the Z limit switch, X limit switch and Y limit switch. These are all 3-pin plugs but only have the positive and negative. These are basically just normally open switches, so we're literally just closing a circuit when they hit. We have the two fans routing in. I am wondering about all of these power and signal lines being run through this same section here, whether or not we'll get any interference. Maybe we'll see. Now there are some places in here to clip, to put in some zip ties, so I think what I will do is just zip tie the motors against these walls and we'll see if that neatens things up. Zip ties. Somewhere I have like a couple of hundred of these, but I couldn't find them, and my local shop is very close, so let's just do this, shall we? Tightened up the wiring down here. This is wired in. These are all the end stops and these are all the motors. Let's do a quick power test. Okay, so it powers on. Fans are good. Got some nice airflow. And nothing jumped into life because we haven't programmed anything. Good start. Quick confession. There's a jumper right here, and this jumper decides whether you feed the fans 5 volts from the board or whatever your voltage in is. These are 5 volt fans. The default for this jumper was my 24 volt input, so I fried 2 fans. But that's fine because I bought a box of 5. So two new fans, jumper set to 5 volts, we're good. Okay, so far so good. That's all fairly straightforward stuff. The trickier part is connecting the Spindle VFD to control. Now I'm gonna say that I've basically just found a really helpful person who's already done this, which is really useful. So let's have a look at that. Basically, somebody on the Open Builds forum has done exactly this for exactly my Spindle and the Duet board. So I'm just going to copy what they did, which is to take this guy here and this picture here. So let me just say this is Tubal on the Open Builds forum. He's got a nice blow by blow of both the G code I need and the wiring. What he did with his is what I'm going to do with mine, which is actually, rather than tuck it inside the Duet case, tuck it in the bottom of the VFD. There's a convenient amount of space there. So I already have two wires that run through all of my cable track and such down to the VFD from where I had the xPro doing this. So I'm going to disconnect those two wires from the voltage inputs on the VFD, plug them both into the pulse width input on this board and replace them with this pair, which will be the 0 to 10 volt analog output. This pair will get connected to a 24 volt and DCM port on the VFD. That provides power for this board. Apparently the board doesn't operate unless it has a power signal. And then the other end of those wires that were previously connected to the xPro will connect to the E0 heater output. Now I'm telling you all this because I'm not really going to show you me groveling around on the floor and wiring this in. I'm just going to go do it, and I might try and get you a close-up of it done. The E0 output, now I have seen people suggesting using the fan output, but because I'm already trying to use 5 volt fans, this thing requires more than 5 volt input on the pulse width modulation to work. So the E0 heater, I think, is the better choice. Sounds like this useful G-code that can just basically allocate that as a tool rather than a heater and blah 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 blah. We'll get to that in a minute. So next thing you're going to see, hopefully, is this thing wired in place, and then maybe we'll be ready to power the thing on and start configuring it. Let's try that. So here's the board, tucked in neatly at the bottom here. The signal pins for the analog out go here and here. Down here there's a 24 volt supply that comes in, and in through the bottom here we have the what will be the PWM input signal. Hopefully that's that. I'm going to talk about what it took to set up the rest of the electronics in a second, but for now, if that'll home, we have the interface up, and I should be able to hit the home all button. And there we are, homed. Pretty cool. And let's not forget the spindle. In theory, I send an M3 S2000 spindle. Let's ramp that up. Let's see how far. Let's take it to 10. Seems pretty good. What does it say on the board? So the VFD says 10.5. So I've had a nice successful homing test. I'm just going to put the lid on this enclosure I haven't tried the probe yet, but I think I'll try that later. So for the configuration part, I haven't really filmed very much. I, broadly speaking, followed the instructions that were available from the Ooznest site. So the key things to note with that really were just I picked the Workbee dual belt, or sorry, the Workbee belted configuration, because this is pretty close to the Workbee really in that sense. I reconfigured everything from having like a normal person homes their CNC to essentially that front corner. But I can't remember why, but for the longest time I only have limit switches on this side and this back, so I always drive to here. I also consider here to be basically 0, 0, and then I drive positively. It's just a thing that I've always done. So I flipped all of those configurations round in the config. The biggest thing that caused me a massive headache was when you first set up the Duet, you plug in a micro USB in order to connect via a terminal and set up essentially like the Wi-Fi connection. Initially I tried to configure to connect to my house Wi-Fi, but signal in here is a little bit sketchy, and it just wasn't getting a connection at all. So I was like, forget it, it doesn't really need to be on the Wi-Fi all the time. I'll just have it host Wi-Fi, which is the other thing that it can do. So I configured that, and I could connect to it. So everything looks like it's going great, right? You like connect via the terminal, issue the commands, tell it to host the Wi-Fi, it shows up as a Wi-Fi hotspot, you connect to the Wi-Fi hotspot, and then you connect to the browser, and what I got was an error saying there were no files in the www folder. And I spun my wheels on that for a while. Just going back and forth, files were definitely there. I thought maybe the SD card was no good. I found the I basically updated the firmware and proved to myself that that file was loaded off the SD card okay, but just wasn't getting it. Found a bunch of places online where people said, you know, maybe that's a dead card or a dead card reader or all that kind of stuff, and it was none of those things. Eventually I realized, whilst everything else looks like it's going okay, it doesn't actually work to host its interface powered only off of the USB. So once you've done that config and you've set it to boot to connect either as an ad hoc host or onto your Wi-Fi, you need to disconnect the Wi-Fi, disconnect the USB, power it off the mains power input, and then the Wi-Fi point comes up, but so does the actual web server. So that killed me for a couple of hours. I felt a little bit silly, but not the most useful thing. Maybe I didn't read that in the instructions somewhere, but that's, once I'd gotten that part out of the way, it really was just follow the instructions on the Ooznest site. And the instructions, I will link to the forum post I found on the Open Builds forum to talk about the Spindle control, which works fantastically. That worked no problem. It was literally changed one piece of config on the VFD to tell it to expect 0 to 10 volts instead of 0 to 5 volts. Easy peasy. Yeah, and as we can see so far, movement it does seem a lot smoother and quieter. I wasn't really sure whether I was going to expect to see or really tell much difference right off the bat like that, but it feels definitely quieter. So the next thing to do is to run my barrage of tests against it, but that is not for this video. This has just been getting it wired up and getting it configured. Next video I'll run the barrage of tests and we'll see how well it does. As you may recall, I always ran my xPro off of a Raspberry Pi and I used BACNC to send signals. So now what I've done is I've connected the Raspberry Pi via the Wi-Fi to the ad hoc connection, and this is what the Duet control board looks like. When you first connect, the first thing it tells you is that the axes are not homed. So as with most controllers, it doesn't let you do anything unless you've homed things. But what I did want to quickly just show was broadly the setup. There's a couple of things that OX suggests you do in their instructions. The first thing is to set up a bunch of macros. So if you go to the workbee configuration and download the workbee firmware zip file, inside of that zip file is a bunch of files including all these macro presets. So you just create, use this to kind of make a new directory to create the folders that need to be there, and then just upload into these folders these various scripts. And these do useful stuff that I would you're going to use every time. The main thing being obviously to set your work coordinates to 0, either all at once or each specific axis that you want to set to 0, which obviously you're going to need to do whenever you set up. The other thing, I guess the key part of all of this that makes the Duet controller work is this config file, which you can edit in here, or you can just take the SD card out and put it in a computer and edit on a normal computer. So a lot of this is basically the same thing, but as you can see I have just copied the version that they had in the workbee config. This isn't a workbee, but hey, I rename mine to be OX CNC. I guess a few key things: it puts it into CNC mode. Here is where we define our drive connection. So this is probably the most critical thing to map correctly to your wiring. So in this case it's just saying 0, 1, 2 and 3 and whether they should be going forwards or backwards. Obviously when you have a dual y-axis, one of them is going backwards and one of them is going forwards, and if they both try to go in the same direction you're going to just twist the machine. So in this case I had to just figure out if all normal axes are going forwards, which one of the two connectors I used for the motor that would be relatively going backwards, and set that one to be S1 instead of S0. And then this little line here basically is the thing that says of all those connectors where we put the wiring, X is the 0 position, Y is position 1 and position 3, and Z is position 2. That's just how that maps out. I haven't changed this. These settings appear to be working. I did a quick test with the ruler. That looks like they're just the standard settings for the NEMA motors that are installed and the threaded rod on the Z-axis. So that all good. Again, this is doing 16th microstepping. I'll leave it as is. And again, speed changes, maximum speeds, I've left all of that to be just the default that workbee comes with. Axis limits for my machine, which is, it's a 1 meter by 1 meter machine, but with the carriage and the movement, that basically works out at about 800 by 770. The key parts of this configuration that I added based on the Open Builds forum post I found. So this is the key section that defines the spindle control as we wired it up onto the board. So I wired the spindle into the E0 heater port. This basically defines a tool of spindle. It says that tool is at no offset from any of the axes, which I guess is interesting. I assume that means you could set up a tool and say, like a pen or something, and say, hey, the pen is always attached at this offset from everything else. Interesting. And then basically down here, these lines here basically disable the heaters to tell it I'm not actually using them as heaters. And then this M453 is a repeat of the set CNC line, but basically it defines a tool of P1, defines a maximum spindle RPM of 24,000, which is about what the spindle can go to, and a frequency, and that is that. Once that's set up, I was able to, with everything wired into the VFD, I can just manually issue M3S whatever commands to create the spindle. What I do notice is the spindle shows up here. I don't know if there's any control mechanism, because this still seems to think that it's a heater. So this, like, I can select it as a tool, but I don't get any kind of obvious control for setting spindle speed like I did with BCNC. But I say, you can literally just set the commands in here to whatever spindle speed you want, hit go, and that will do the business. So if I hit home all, you can hear in the background it doing exactly that. And then it will know that it has finished homing, and it's interesting that these go blue as it successfully detects them homed, at which point you are now able to move them, and boom, there's X. And then you just get into normal control mode where you can say what you want to do. It's interesting that these defaults are laid out. I don't know if there's a way to have any more control on B, C, and C. You could literally just hit like a multiplier number to set whatever distance you wanted to move, whereas it looks like these are just hardwired to like 0.1, 1, 10, 50, 100 in each direction. We'll see how much of a problem that ends up being. Once homed, obviously I've told it that when it's finished homing, it should consider itself at x0, y0, but z94. So I'm coming minus down into the bed with z, because normally I would set 0 being like the surface of what I'm milling, and I would be milling into the negatives. So I want down on the z-axis to be kind of minusing, whereas I would normally also set my work coordinates as essentially 0, 0 on the bottom left corner of what I'm working on. Anyway, that tells you where you are. You can press the buttons to move forwards, and you see that this updates to there, and then those macros that we set up appear over here. So you can say switch to work coordinates. This has just remembered where I am relative to the last time I set work coordinates. So if this happened to be the location I wanted, I could say set work coordinates. These would all go to 0, and now that's where your work coordinate system is. So all of that to say, we're up and running. We've got control. I guess the next thing to do will be to load up some G-code and actually give it a whirl. For now, this is the wiring and setup done. The thing moves. Thanks for watching. See you next time.